Hi guys, this is AS Chemistry, Analytical Chemistry, and we are doing infrared spectroscopy. Question 1. Give the structural formula of a pair of positional isomers with the formula C4H8O2 that are esters. So, because we've got esters, so we have the C double bond O single bond O group present. So, first we make that group. Now, that we have made the ester group, now we're left with 3 carbon atoms. So on one of the esters, we can have a CH3 group here, a CH2 group here, and a CH3 group here. And on the other one, we can have a CH2 and a CH3 group on this side of the C double bond O group and a CH3 group on this side of the oxygen atom. So in this way, we have made 2 positional isomers which are esters. The name of these esters would be, in the case of the first one, it would be ethyl ethanoate because both sides have 2 carbon atoms. And the case of the second ester, it would be methyl, and there are 3 carbon atoms on this side, so propanoate. The infrared spectra of one of the esters and of another isomer X are shown. X decolorizes bromine, water, and is not an ester or an acid. So the infrared spectrum of ester is shown here. So we can see that we have a C single bond O group and a C double bond O group present on this infrared spectrum for the ester. This is the infrared spectrum of X. So the peaks that are clearly visible are the OH group for the alcohol, and we've got a peak near 1500, which is basically, according to the question, not a carboxylic acid or ester. So if we look at the infrared absorption table, this corresponds to a C double bond C or an alkene group. So we have a peak for an alkene group and a peak for the OH group in the infrared spectrum of X. Explain the difference between these two spectra with particular reference to the peaks with the wave numbers above 1500 centimeter inverse. So we can say that in ester, a peak in the range 1710 to 1750. This value is taken from the infrared spectrum absorption table. Centimeter inverse can be found for a C double bond O group, and we can say that in X, a peak in the range, now for C double bond C, the range is 1500 to 1680. So 1500 to 1680 centimeter inverse can be found for C double bond C group, and in the range 3200 to 3600 centimeter inverse for the OH group. So we can have 2 peaks here, C double bond C and OH, and a peak C double bond O in the ester. So that's how we can differentiate between compound X and the ester. Question 2. CH3, CH2 tri C double H, this is pentanoic acid, is a colorless liquid with an unpleasant odor. It reacts with methanol in the presence of an acid catalyst to produce an organic product V which has a pleasant fruity smell. So V will be an ester where the methyl group will be attached to the carboxylic group. Name V. So this would be methyl and it is pentanoic acid, so pentanoate. A student analyzed pentanoic acid, methanol, and methyl pentanoate using infrared spectroscopy. The spectra were returned to the student without labels. Identify which of the infrared spectra X, Y, or Z corresponds to V. Okay, so we need to identify which spectra corresponds to V, which means it is methyl pentanoate. So in infrared spectrum X, we can see a peak for C single bond O, a C double bond O, and a C single bond H. In infrared spectrum Y, we can see a peak for C single bond O, and we can see a peak for OH and for CH. So this corresponds to an alcohol. The spectrum X apparently corresponds to an ester. Infrared spectrum Z has a peak for a C double bond O group and a peak for the OH group in the range in which the OH should be attached to a C double bond O group. So this corresponds to a carboxylic acid. So X is for an ester, Y is for an alcohol, and Z is for a carboxylic acid. Identify which of the infrared spectra X, Y, or Z corresponds to V. So we have identified Z as the carboxylic acid, Y as the alcohol, and X as the ester. Okay. Explain your answer with reference to relevant features of the three spectra in the region above 1500. In the region above 1500. So in the region above 1500, X and Z show a peak in the region of 1710 to 1750 corresponding to a C double bond O group. That is one of the features visible. Then we can see that Y and Z shows a peak for the OH group in the region of 2500 to 3000 centimeter inverse, and Y, or rather V is X, right? So X has a C double bond O group present and no OH group present. It also has a peak for C single bond O group, confirming its identity as an ester. Question 3. H and I are isomers with molecular formula C2H4O2. The infrared spectra of isomer H and I are shown. Okay, so the peaks visible in H are C single bond O, C double bond O, and OH that is bonded to a C double bond O group according to its wave number region. In I, the only peak visible is the peak due to a C double bond O group and nothing else, which also gives us a doubt that this could also be a peak due to C double bond C because both of these peaks lie in the same region as the peak shown in this spectrum. However, since the molecular formula contains uh, two oxygen atoms, so this peak is not due to the C double bond C group and is definitely due to the C double bond O group. Also, the peak closer to 1200 could be due to a C single bond O group, and the peak that is not that sharp, it is nearing 3000, could be due to a CH group. It is a weak peak. So the only confirmed peak here is the C double bond O group peak. Identify the bonds responsible for the principal peaks above 1500 centimeter inverse in each spectrum. So in spectrum H, we've got a peak for the C double bond O group and a peak for the OH group that is part of the C double OH group. And in spectrum I, we have got a C double bond O group present and a weak peak for a CH bond as well. So, and these are above 1500 because if we look at the entire spectrum, we have a C single bond O peak present in both. So, since spectrum H contains the OH group, that means it has to be a carboxylic acid. So, the molecular formula given to us was C2H4O2. So, a 2 carbon carboxylic acid is called ethanoic acid, and a 2 carbon ester, which would be I, would be methyl methanoate. So the structure for ethanoic acid would be CH3 COOH, and the structure for methyl methanoate would be HC double bond O single bond O CH3. So that would also correspond with the formula C2H4O2. Question 4. The product of reaction 2 is cyclohexene. Cyclohexene can be converted into adipic acid, which is hexane dioic acid. Identify the reagent and conditions for the conversion of cyclohexene into adipic acid. So we need to break this bond, and on each of the carbon atoms, we need to place C double OH, which means what we need is hot, concentrated, acidified KMNO4 to bring about the oxidation of the cycloalkene to form a dioic acid. Suggest three main differences between the infrared spectra of cyclohexene and adipic acid. In each case, identify the bond responsible and the characteristic absorption range in wave numbers. So, for cyclohexene, we would have a peak corresponding to C double bond C present in the range of, and this range would be 1500 to 1680 wave numbers. So this peak would correspond to the double bonded carbon atoms in cyclohexene. And the other one is a carboxylic acid. So for adipic acid, a peak corresponding to C double bond O should be present in the range of 1670 to 1740 wave numbers. And again for adipic acid, we would have a peak corresponding to OH from COOH present in the range of 2500 to 3000 wave numbers. So these are the differences between the two compounds and their infrared spectra that would help us differentiate between them. Question 5. A different trihalomethane CaCl3 reacts with O2 to produce carbonyl dichloride. HCl is also released as a product of this reaction. So carbonyl dichloride is given COCl2. Write an equation for the reaction of CH3Cl with O2. So CH3Cl plus O2 products are COCl2 plus HCl. So what we need is the removal of a hydrogen, but the compound given here is CHCl3, not CH3Cl. So we change that up a bit. We end up with CHCl3. Okay, so that makes it easier because we need to lose one hydrogen and add one oxygen. So we need half mole of O2. So that adds one atom of oxygen and removes an HCl molecule. And this is the balanced equation. The conversion of CHCl3 to carbonyl dichloride can be monitored by infrared spectroscopy. The infrared spectrum of carbonyl dichloride is shown. So here we can see the C double bond O group present. On the infrared spectrum of carbonyl dichloride, identify with an X the absorption that would not be present in infrared spectrum of CaCl3, which is this only. So this is equal to X, this peak, and explain your answer. CHCl3 does not have a C double bond O group present. Suggest another difference between the infrared spectra of CHCl3 and carbonyl dichloride. So CHCl3 would have a peak in the range of 2850 to 2950 wave numbers for the CH bond, which will be absent in COCl2, carbonyl dichloride, because carbonyl dichloride will not have any CH bonds present in it because there are no hydrogen atoms present in carbonyl dichloride. Question 6. P, Q, and R all contain 5 carbon atoms. Okay, P is a nitrile, is a hydroxynitrile, Q is a ketone, and R is an alkene and an aldehyde. Okay, the infrared spectrum shown corresponds to one of P, Q, and R. Okay, so identifiable peaks. We have a C single bond O, we've got a CH, which is there in all the three compounds. C single bond O is only there in P because all the rest of them have a C double bond O group. And we have an OH group corresponding to an alcohol, and that is only there in P. So this structure appears to be P. And we've got another peak closer to 2200 wave numbers, which corresponds to a C triple bond N. And this was checked because compound P contains C triple bond N. So a C triple bond N peak is present in the range of 2200 to 2250, a very, very narrow range. And this peak seems to be present in the given infrared spectrum. Deduce which of the compounds P, Q, or R produces the spectrum. Explain your reasoning. In your answer, identify any relevant absorptions in the infrared spectrum and the bonds that correspond to these absorptions in the region above 1500. So that eliminates the C single bond O. So the compound is compound P, and explanation is a peak in the range of 2200 to 2250 wave numbers for the C triple bond N group is present, and we can also include a peak in the range of 3200 to 3600 wave numbers for the OH group is also present. So a hydroxynitrile would have both of these peaks present in its infrared spectrum. Therefore, the compound that has its infrared spectrum displayed here is compound P.